Math 157ers. This is Professor D with a short recording about the binomial distribution. Excuse me. The binomial model, it applies if there are a fixed number of trials, there are only two outcomes possible, yes or no, success or failure, heads or tails. The probability of success, P, is the same for each trial. For example, the probability of flipping a fair coin and getting a head is 1 out of 2, or 0.5 for the first trial, the second trial, all the way up to the 1,000th trial. Trials are independent of each other. When you flip that coin, the first trial and the fifth trial, they have no bearing on each other. So the question is, here are a few examples, and let's determine whether or not they are binomial. 4 randomly selected college students were asked if they selected their major in order to get a good job. Is this binomial? Does it answer a yes or no question? It is, because they could say yes, they selected their major to get a good job, or no, they did not select their major to get a good job. 35 randomly selected Americans were asked what country their mothers were born in. In this example, it's not binomial because there are more than 2 possible answers. Now, in order to make this binomial, you could ask them if their mothers were born in the United States or not. But when you can have multiple answers, it's no longer binomial. To estimate the probability that students will pass an exam, the professor records a study group's success on the exam. What do you think? It's not binomial. The outcomes are not independent. It is a study group. Perhaps the study group studying together will give them a better outcome. So let's talk about surveys and independence. Binomial model may be used if the respondents of a survey are selected with replacement. If the selection is done without replacement, which is pretty standard, because you're not going to put somebody back into the pool of people that you can ask. And the population size is at least 10 times larger than the sample size, then we may still use the binomial model as an approximation. So this second statement is really what we have to keep in mind. If you take a sample size of 50 and you are trying to get some information about enroll students at TCC, well, our population is approximately 40,000, so 10 times 50 is 500. And so the actual population is 10 times greater than your sample size, so it would be okay to use the binomial model. Let's look at what the binomial distribution looks like. Here you have 8 trials, and the probability of success on any given trial is 0.2. Now this looks a little bit more normal. Here our n is equal to 12, and the probability of success is 0.4. Well, that's getting closer to 0.5. That makes sense. That would start to follow a more normal model. Plus, as our n increases, our data is going to look better. Again, look at our sample size is much bigger. My probability of success is 0.6. Looks better. Looks like a more normal model. So when n is large and p is close to 0.5, the binomial distribution will be approximately normal. Now, when you're working on your homework, these words and inequalities are really key to setting up the problems right. There's the word exactly, less than, at least, more than, at most. So exactly would be an equal sign. These are a little bit off. Less than, you have the less than sign. At least, that's going to be greater than or equal to. At least 5, greater than or equal to 5. More than, at most, less than or equal to. So keep these in mind when you're trying to set up a binomial model to solve in your homework, because you really have to make sure you set up your inequality correctly. right? Less than and at least, they complement each other. More than, at most, they also complement each other. So how do we find a binomial probability? 12% of all U.S. women will eventually develop breast cancer. If 30 women are randomly selected, so our N in this case is 30, what is the probability that exactly 4 of them will eventually develop breast cancer? So this is a binomial distribution. Did not mean to go there. Binomial. You go N, P, X. N is our sample size. P is the probability of success. Success here is defined as getting breast cancer. And 4 is what we're looking for. At this point, I'm going to switch to Windows because we're going to use the calculator on the online stat book. You may use the calculator on the TI. There are videos inside the readings and videos section about how to use the TI calculator. Let's hit escape. Binomial distribution. Here's the binomial calculator. Our N is 30, and the probability of developing breast cancer was 12%. So that's what goes in this pie. That's our probability. And I need exactly 4. So the best way to use this calculator for exactly 4 is to put between 4 and 4 inclusive. So the probability that exactly 4 women out of 30 will develop breast cancer is 0.2047, about 20.5% if you were thinking it that way. Okay. Let's look at another example. 14% of all clothing bought online is returned. If an online retailer sells 35 items of clothing, what are the following probabilities? At least 5 will be returned. So that is going to translate to greater than or equal to 5. Over here we had 45 is our sample size, 14%, 0.14, and we can use the above at least 5. So at least 5 would be above 4. Above 4. Probability is 0.7739. I could also set it as between 5 and 45 inclusive, and I get the same one. So you can set them up slightly differently. Often people like to use the between because it's a little bit more straightforward. So that probability that at least 5 items will be returned is 0.7739. You know what? Oh, it was 35 items. That's why I got it wrong. Let's just put the right number in here. And there you go. Fewer than 7 will be returned. So we can approach this a couple of ways. Well, fewer than 7 could be between 0 and 6. How else could we do that? Below 7. And you get the same answer, 0.7892. So fewer than 7 because this below does not include the 7. More than 6. So that is really 7 through 35 items would be returned. So I could do above 6 because that does not include 6. 0.2108. Does that sound right? I could also say between 7 and 35 and get the same answer. There's more than one ways to solve them, but it's using the binomial calculator really simplifies the process. At most 4. At most 4. So at most 4 does include 4. So I could do below 5 because that would include from 0 through 4. Okay, 0.446. I could also say between 0 and 4, 0.446. Last topic in here is the expected value. We'll come to the standard deviation in a second. If you roll a 6-sided die 30 times, how often would we expect to roll a 2? Well, on any one roll, we would expect to get a 2 1 out of 6 times. So when we're dealing with a binomial distribution and we want to find the expected value, it's also called the mean, it is equal to n times p. So it's the number of trials times the probability of getting that result in any one trial. So again, if I roll 30 times and I have a probability every 1 out of 6 times I should roll a 2, my n is 30, my p is 1 out of 6, so 30 times 1 out of 6 is 5. I should expect to roll a 2 about 5 times. If I was looking for the standard deviation of a binomial distribution, the formula is the square root of n times p, parentheses 1 minus p. So my number of trials, my probability of success on any one given trial, multiplied by 1 minus the probability of success on any one trial, and then you will take the square root. So on any particular day, there is a 6% chance of a fatal accident in the city. Find the mean and the standard deviation for the number of accidents in a 365-day year. So the first thing we'll do is the mean. N is the number of trials, which is 365 days. And on each day, there's a 6% chance of a fatal accident. So my 6% is equal to 0.06, 21.9. Okay? So in a year, I would expect to have about 22 accidents. Standard deviation is n times p times 1 minus p. You take the square root of that, and we get 4.5. So on average, in a year, we would expect about 22 fatal accidents, give or take 4 or 5 accidents. And that is it for a short video to get you ready for the binomial distribution. A link to these slides, they're Google slides, will also be included in the reading and video section. Thank you.